Good morning, class. Welcome to Monday. Today we're going to take a look at section 12.2, and as Mr. Johnson said, you may have wanted to pick up one or two colored pencils. Hope you have them at your desk, and we are ready to rock and roll. So section 12.2 is about pyramids, and I think you can tell that they're different from section 12.1 where we had prisms, because as I showed you on Friday, prisms had two bases, but pyramids, as you can see, they only have that one base. So in our notes here, we're going to write down that a pyramid has one base and a vertex. And in my example over here on the right, the vertex is point E. I'm going to add a few tick marks to the picture. I'm going to tell you that those two sides are the same and that those two sides are the same. Now, we talked about the altitude on Friday in reference to the prism, and today with the pyramid, the altitude is the segment from the vertex. It's still perpendicular to the base at the center of the base. So I'm going to go ahead and draw that puppy in. And just like on Friday, the height, which we'll label H in the picture, is the length of the altitude. Now, the lateral faces. Yeah, Friday we learned that the lateral faces were the faces that were not the bases. Same thing works here. But in a pyramid, the lateral faces are triangles. Unlike in the prism, if you remember, we called them p-grams. The next bullet down. There's a typo. That should say a lateral edge, so we got to cross off that S there. A lateral edge connects the vertex to the base. So if I asked you, by looking at that picture, what would the lateral edges be? If you're saying segment EC, segment ED, segment EB, and segment EA, you would be exactly correct and you'd win the prize. Now, a new term is going to appear now that we're talking about pyramids, and that's something called a slant height. Math books label it with a script letter lowercase l, and what that is, a slant height is the height of a lateral face. So if I draw one in my diagram, it's going to come from the vertex, and it'll be perpendicular to one of the base edges. And that is considered to be a slant height. Now if I want to name this pyramid, just like with the prism, you name a pyramid using its base. So this example I would consider to be a rectangular pyramid. Now, a majority of our time is going to be spent dealing with things that are called regular pyramids. So why is it called a regular pyramid? The reason is the base is a regular polygon. If you remember what that means, all sides and all angles are congruent in a regular polygon. Now, since it's a regular pyramid, not only is the base a regular polygon, but all of the lateral edges are congruent segments. So if I'd mark those, that would now mean that I could change the shape of the lateral face. No longer is it just any old triangle. It is you're right, it is an isosceles triangle. You guys are so good. You must have read ahead. Well, obviously now that we have a new figure, we have to have some new formulas. So, same information as we had with the prism. Our lateral area is LA, and that is the sum of the area of the lateral faces, which again are triangles. The base area, which again is the letter B, and this is the area of one base. And the total area, which again we'll call TA, is the sum of the area of all of the faces. And what would be my total area formula for a pyramid? If you thought to yourself that total area should be the lateral area plus just the B, you're right. Because remember, pyramids only have one base, where prisms have two. Okay, just like on class on Friday, I'd like to develop or create for you the lateral area formula for a right pyramid. So got to do a little bit of labeling in our picture. So we're going to label the bases, the base edges as A, B, and C. Then I need one more thing. I'm going to add a slant height, just one of them. Again, remember the slant height is the height that is used in each of the lateral faces. All right, so how would I find the lateral area? Well, I said that it's adding up the area of all of the lateral faces, and each face that's lateral happens to be a triangle. And I recall that the area of a triangle is 1/2 base times height. So if I wanted to find the area of one of the triangles, I could say it's 1/2 times the base of C times the height of that face is the slant height, L, plus 1/2, say the triangle in the front has a base of B, and its height, again, is the slant height, L, plus 1/2 times A times the slant height, L. Again, remember what I'm trying to do here. I'm trying to create the formula for you. Where does it come from? Well, using my algebra skills, I see a GCF of 1/2 L in each of those terms. What's left behind is a C plus a B plus an A. You think back to Friday, I asked this question. I said, what does C plus B plus A represent in my diagram? And if you remember on Friday, we said that was the perimeter of the base. So maybe you can guess what I'm going to write down now as our formula for lateral area. So up here I have the 1/2 L times P, and that P is going to stand for the perimeter of the base. All right. Volume. We're going to skip the first bullet on the notes. When I'm back in class on Tuesday, I will go through and show you where the relationship exists. It's kind of interesting. We're going to jump down to the second bullet here, and I'm going to tell you straight up what the volume formula is for a regular pyramid. And that is the volume of a regular pyramid is 1/3 big B times H. So one more formula to add to your collection. All right, let's try a couple examples. And I'll be honest with you, finding stuff within a pyramid sometimes can make you scratch your head and sit back and go, huh? So have your thinking skills available, and let's get this one started. It says, find the exact total area and exact volume for the given figure. First off, what would I name it? Well, if I can see here that I have a 12 and a 12, that's going to make that bottom a square, so I would call it a square pyramid. And to find the total area, our formula said we needed the lateral area and the base area. Well, I say let's do the base area first, because to me that's really straightforward. It's a square. So the base area is going to be 12 times 12, which we know is 144. Got the easy part out of the way. Next, lateral area. The formula is 1/2 the slant height times the perimeter. All right, what do we know? What don't we know? Well, we probably should draw a slant height in the picture. So right there, I will put my slant height L. Now the next thing, if you realize this is the height of our figure, and it is perpendicular to the base. And remember that the height hits the base at its center. So I can make me a handy dandy triangle right there inside of that pyramid. And we should know the length of this red segment that I drew in here. Remember, the height hits at the center. So this segment right here has to have a length of 6. So, do you see what I see? Do you see a way that I could figure out the slant height? Because that's what I need to know. If you said Pythagorean theorem, you're right on. So the slant height squared is going to equal the 10 squared plus the 6 squared. So let's see, 10 squared is 100, 6 squared is 36. That comes out to be 136. Take the square root. Now, it's that exact answer. That means if there are any square roots, I leave the square roots in my answers. So if I check my perfects, you'd find out that 4 does divide into 136. So the slant height is 2 root 34. And I'm going to leave it just like that because it's that exact answer. Let's plug our stuff in. So my slant height is 2 root 34. Perimeter of the base, you know that. All the sides are 12. 12 times 4, I'm going to go with 48. So if I do the number crunching on that, I'm going to come up with 48 root 34. So my total area is my lateral area of 48 root 34 plus my base area of 144. And since it's area, it's units squared. Oofta. A lot of work for one problem. How about the volume? Well, our volume formula is 1/3 base area times height. How much number crunching do I have to do here? Let's see. Do I know the base area? Why, yes. It's right here. It's 144. Do I know the height? Look at the picture. Aha! It's 10. This time I just got to plug the numbers in. So that would come out to be 1/3 times 144 times 10, which for me came out to be 480. So my volume should be 480 units cubed. Let's try one more. Find the volume for the given figure. Round your answer to the nearest hundredth. Notice here it says round your answer to the nearest hundredth. So no radicals left in my answers this time. The figure is a regular triangular pyramid. Let's see, base edge is 6. Let's add that. So that means these are 6s. It's regular, so they're all the same. And the slant height is 8. All right. So I need volume. And the volume formula is volume equals 1/3 base area times height, which I know neither of. I'm going to work on base area first. So come over here on the right. What's the base? It said it's a regular triangular pyramid, which means the base has to be an, if you guess equilateral triangle, you win another prize. So it's a regular pyramid. It's a regular polygon. That's dead center. So go back to last chapter. That little triangle I just put in there, you're right. That's a 30-degree angle. That's a 60-degree angle. Do I know anything else? Well, if the whole side is 6, that means that part's got to be 3. How am I going to find the base area? Well, base area has to be 1/2 the apothem times the perimeter. Remember, that base is a regular polygon. All right, so here's the apothem right here. 30, 60, 90 triangle. You're right. Take 3, divide it by √3, and I'll clean it up. Boils down to just a √3. We can now find our base area. So that's 1/2 times √3. Perimeter, add all the sides up. 6 plus 6 plus 6 is 18. So that looks like a 9√3 for me. Now I'm going to let that as a √3. I'm going to worry about the 100th decimal answer when I get down to the bottom. So let's just let that be for a minute. All right, volume. Let's see. We got our big B. Now we need our height. All right, let's go in our picture here. We might as well draw it in. That always makes a right triangle for you. So here's our height. Now remember, this is the center of the base. So what is that guy right there if that's the center of the base? Remember, this is the center of the base as well. So if you're saying this is the apothem right here, again, another prize for your cause. So what I'm going to do is I'm going to pull that right triangle out and draw it on my paper over here. So this is the height, which we don't know. This is our slant height, which is 8. And this is the apothem, which we figured out over on the right as root 3. So now I can find the height with Pythagorean theorem. So that's going to be h squared equals h squared plus root 3 squared. So 64 equals h squared plus 3. So it looks like h equals root 61. And I'm going to leave that again until I get down to the bottom for finding out my volume. All right, so my volume equals 1/3 the base area times the height again. Now we have all of that. That's 1/3. Our base area was 9 root 3. Our height is root 61. If I number crunch that, I'm going to have 1/3 times 9 is 3, and root 3 times root 61 is root 183. If it said exact answer, I stop the bus and get off. But it didn't. It said approximated of nearest hundredth. So when I magic boxed it, if I did it right, I had 40.58 units cubed. Wouldn't be bad if you checked your magic box and see if I did it correctly. Well, my little chickadees, that concludes section 12.2. Hope you enjoyed the lesson. Hope you felt like I was still here with you. And I got to tell you that that's a lot of stuff, a lot of number crunching. So Mr. Johnson will now give you the assignment, and you'll be good to go. All right, peace out. Mad love, do math. Yeah. Just got to shut this puppy down. There we go.